All right, so we're still in chapter 1, so we're doing a lot of introductory things. So this lesson is very basic angles. Okay, we're going to talk about angles all year long. These are just specifically angles all by themselves. We're going to talk about angles in polygons, all sorts of stuff. But this is just an introduction to them, talking about how to name them, a whole bunch of stuff like that. So we'll start by talking about what the definition of an angle is. It's just two rays. Here are the two rays with the same endpoint. That endpoint that they share right here is called the vertex. So draw an arrow to that. The sides are simply the rays. So if I ever talk about the vertex, I'm talking about the corner of the angle where the two rays meet together. Okay, there's three ways to name an angle. So here's three different pictures. Now, when we were learning how to name segments and lines and planes, there's all those different ways to properly name those objects. There's also different ways to name angles, but all of them involve drawing an angle symbol in front of whatever the name of the angle is. Okay, now I don't want you to write less than A. Okay, that's not good. Tell me the difference between less than A and angle A. They're very close, but what's different between what you see up here? Yes?
Is like angle A like more like flat?
Yes. At the bottom, it's horizontal. Okay, I don't want you to write less than A. So make sure that you're paying attention to that when you're writing that notation, so I know you're talking about angle A. What do you think the middle one is called?
Angle 3.
Yes, angle 3. Okay, so the first two are really easy. If they just give you a single letter or a single number, you just call it by that letter or number. Now, if they give you three letters on the angle, you have to do them in a certain order. Okay, the order needs to wrap around the angle, and you can go either direction, but you can't hop, skip, and jump all over the place. It has to go in order, wrapping around the angle you're talking about. So it could be XTM, or the other way, MTX, making sure that that middle letter is your vertex, which is T on this angle. Questions on that? So they're going to assume that you know that in the homework, and I'm going to assume you know that for the test. Just make sure it wraps around the angle. Sometimes it helps to kind of trace your finger over the letters in order so that you know which angle they're talking about. Sometimes there's 10 angles on one picture. They give you 3 letters. If you connect those 3 letters, you know exactly what angle they're specifying. All right, the book is going to use this notation because this is really long. Okay, this little m means the measure of. Obviously, this is the angle symbol. We just learned that. The measure of angle A is 80 degrees. They're assuming you know that they're referring to degrees, not inches or feet or whatever. The unit is degrees on there, and they're not going to put the degrees symbol. They're just going to shorten it up like that. So just know that that's what they mean when you see that. Questions on the basics with angles here? Okay, that's the groundwork that we're going to use in the rest of the notes. All right, how to use your protractor. Most of you have used one of these before, so this will be a review, but we're going to write down some tips as we go along. So who knows what we should be focusing on first when we place the protractor on your screen so that you can measure that? What are we paying attention to? Go ahead.
The vertex goes in those.
Yep, there's a hole in the middle of the protractor right here. Okay, that needs to go on the vertex, so I'm going to write that first. Okay, so I'm going to do that. What else are you being careful to do when you lay the protractor on there at this point? For instance, what if I just plop it down like that? What do you want to be careful to do? Obviously that center hole is going to be lined up with the vertex, but what else needs to be lined up? Yeah. The 0 line, or there's usually a black line drawn right on your protractor. So you're going to want to line that up with one of the sides, and it does not matter which side you line it up with. So on your iPad, if you could lay it flat, actually put your protractor on there. I want all of you to measure it. We should all get the same answer. Okay, we should all be looking right here. I'm going to write down the other tip here. There's always going to be two options here. Okay, there's going to be a bigger number and a smaller number. Most common mistake on using the protractor is picking the wrong number. Okay, so let's talk about what we can do. So right here, it looks like I have two options, either 131 or 49 crossing through. If you're within a degree or two, either direction, I'll give you credit for that on the test because I'm going to ask you to measure an angle. So if you're close, within 2 degrees, either direction of the numbers that I pick when I measure it, you're good to go. But you do have to pick the right one. So looking at this angle, which one is it? Yeah. Why? Because it's not obtuse, which means it's less than 90. So 90 is really where you want to gauge everything, a right angle. Okay, like the corner of a piece of paper. If it's less than 90, pick the number less than 90. If it's more than 90, pick the number bigger than 90. Okay, so we're going to pick this one because it's an acute angle less than 90. So let's just remind yourself to pick the right number. And we had that discussion on which one to pick just now. Okay, so I'm going to follow these tips that you guys told me on this one. But something doesn't look right. What do you sometimes have to do? Flip the angle or flip the protractor would be a little bit easier. Sometimes you can flip your paper. I can't flip my smartboard very easily, so I'm going to do this. And just because you can pick either side, I'm going to line it up with that side instead of the horizontal one. We should get the same answer. You can line it up with the one on the top if you want to. And then you look where the other ray crosses through. Okay, so I did the red step here, line the vertex and the hole up, line up the black line with a side. Now we need to just pick the right number. What are my two numbers? Estimate. What would you say my two numbers would be? What's one of them?
52.
52 or? Okay, which one is it? Is it bigger or smaller than 90, this picture?
Bigger.
Bigger, so we're going to want to pick the one that's bigger than 90. Questions? You don't need to give me both answers and then circle the right one. You can just tell me the right one. I'm just going through that process to make sure that you slow down and ask yourself, okay, which number should I pick here? Don't just automatically pick the number that's closest to the middle of the protractor, okay? Questions on that? Can we move on? All right, so I'm looking for the names. We've actually already talked about some of these. What would the names that you could classify these angles by? This is review from elementary school here. Yes. That's the first one. Next one. Next one. And the last one is not as common, so some of you may not remember this one. What kind of angle is that? It's a straight angle. Good. So really quickly, acute has to be, what's the rule?
Smaller.
Yep. A right angle is 90. This one is
Over 90.
what does this one have to be?
180.
180. Okay. Keep that 180 straight angle in mind when you're doing the homework. Okay, so that's review. A good review. I'm going to ask you those on the test. So I don't want you to measure these with your protractor. We're just going to estimate. Okay? What would you guess the first one is? Yeah, that one definitely looks like a right angle. About how much would you say the next one is?
45.
I would say about 45. Here's a good way to estimate is to draw the 90 degrees and ask yourself if it looks like it's going about halfway through. Okay, so that one I would guess would be about 1 or 45. And how many degrees on the last one would you say?
135.
135. Okay. Let me draw in some of these that we're more familiar with. Would you say 135? 90 plus another 45? Sure, somewhere around there. Okay, if I ask you to estimate, I'm going to give you a pretty large range as far as correct answers. But it's always good to be able to quickly estimate how big an angle should be. Questions there? Okay, let's move on. All right, angle addition postulate. Remember, postulate just means a geometry rule that we accept. First of all, let's draw in ray SP. So remember when we were talking about segment addition, we had this part of the segment plus this part of the segment equals the whole thing. The same thing is with angles. This angle plus the angle next to it equals the whole angle. So that's what this is saying right here. We're going to color code some of this. So I'm going to underline, kind of make a key here. I'm going to highlight this angle with a black arc. So if we follow those 3 letters, this is one of those situations where we have 3 letters for naming an angle. Remember, if you trace along the letters in order, it will draw the angle. So R, S, T, that's talking about this whole angle right here, RST. Let's use a different color. We'll use red for this one. RSP, let's follow those. RS to P, we're talking about that angle. And this last one, PST, is talking about this angle. Okay, so what this equation is saying, which really makes a lot of sense, is that if you add together the red and the green angles, it should equal whatever the whole angle is equal to. So we're going to be setting up algebraic equations, similar to when we had segments. This part plus this part equals the whole thing. Okay? Questions on that? So let's try that with this picture. Part, here's our theme we're going with. Part plus the other part equals the whole angle. So that's how we're going to set it up. Okay? It is a mirror image of what's up here, but it doesn't matter where that angle RST is going to go. You can put it on the other end. So we'll do it similar to how we were looking at the segments in the previous section. So here's our picture right here. What are these 2 parts as far as algebra that I'm going to write down to add together? What 2 parts would I write for the algebra on this picture right here? Remember, this is the geometry part of it, and we want to turn it into algebra. Yes?
2x plus 2 and x plus 1.
Yep, these 2 angles right here. This one and this one. Those are the 2 pieces of the angle. So 2x plus 2 and x plus 1. And it has to equal the whole thing. What is the whole thing? How big is the whole angle?
90.
How do you know 90?
I just got that little.
Now 90 degrees is the only angle that has a special symbol that goes with it, okay, which is a square in the corner. There is no other angle that has a image that you should automatically know is linked to a number. Okay, so if you see that square, you know it's talking about a 90-degree angle. So now it's algebra, and we can simply solve for x. We need to combine like terms over here, which would be subtract 3 and divide by 3. What do we get? 29. Now here's the question. We haven't answered the question yet. Find the measure of the smaller angle. Which one is the smaller angle? Yep, this one right here. We want to know how many degrees are really in there. How many? 30, because we put our 29 right here. That's what we figured out. So the answer, 30 degrees. So make sure you're paying attention to the directions. Some of them want you to just find x and stop there. Others just want you to substitute it back into one of the expressions over there. Questions on this setup? The part plus the part equals the whole? I have one slide left. Anyone still need this one? Okay. Couple of things. Angles are congruent when they have the same measure, just like segments are congruent when they have the same length. So if they have the same degrees, 37 degrees and 37 degrees, then they're congruent to each other. Remember, equals and congruent are nearly the same thing. This one just is dealing with numbers, and this is referring to the pictures or the objects. So just know that essentially that means the same thing. All right, so if you have congruent angles, there's certain markings that you're going to see. So this is really, really important. Let's review what we talked about with segments. If I have this segment and this segment, and they're congruent to each other, what symbol will you see on them? They're the same length. Some dashes. Okay, the same number of dashes. So it might be 2 dashes each, or 3, or 1. So it's going to be really similar to that with angles. It's the same number of arcs. Okay, so if you see 2 arcs here and 2 arcs here, that means they're the same measure. Or they could have just 1 arc. And that would mean they're the same measure. Well, if they're the same measure, what would you do with the algebra when you set it up? Would you add them together and set them equal to something?
No.
No. What would you do? Let's say this was 2x and this was 4x minus 1. I just made that up. I put that on there. What would you do with those two things?
Set them equal to each other.
Right. If the angles are equal, then the algebra is equal too. So we've got 2x equals 4x minus 1. We're not going to go through and solve that because it probably won't end up working out. But that's how you would set up an equation if you saw those symbols. Okay, another thing that creates equal angles is what's called an angle bisector. Now, angles don't have midpoints like segments do, but they do get cut in half with an angle bisector. So this right here is the object that is cutting that angle in half. Well, if something gets cut in half, what do we know about these two angles then? Yeah, because it gets cut right down the middle. So this angle will be equal to this angle. So in the homework and also on the test, anytime you see bisector or it got bisected, you now have 2 equal parts. So you can set them equal to each other. So it would be similar to what we have up here. Questions? So essentially today, we talked about measuring angles, and then we also talked about adding 2 angles together and equaling the total angle measure, or setting them equal to each other if they're congruent. That's really all of the homework and what you're going to be doing. Any other questions?